Hey guys, so for tonight's homework, you were supposed to practice these problems and then I am going to go over them in case you have questions. So what I'm going to do is for each problem, I'm going to give you guys the answer, and then if you got that answer, you can actually move on to the next problem and check your next answer, or if you got it wrong, you can just follow the video and I'll explain each problem. So for number 1, the answers are x equals 37.5 degrees, y equals 57.5 degrees, and then z equals 85 degrees. So if you got these right, feel free to go to the next problem and check those. Okay, if you did not get these correct, let's go over this problem. So we're given a circle, we have a tangent line at the bottom, and we have a bunch of chords that are creating inscribed angles inside of the circle. We are given that arc AC is 115 degrees, so let's go ahead and label that. We're also given arc BC is 75 degrees. And we're just trying to find these angles that are inside the circle, X, Y, and Z. Now these angles are all inscribed angles. So let's start with angle X. When you highlight angle X, its intercepted arc is going to be this 75-degree arc. So the rule for inscribed angles is that it's going to be half of the arc. So you're just going to do 75 divided by 2. That's how you get 37.5. All right, if I were to look at angle Y, so I'll highlight this in blue. Angle Y is also an inscribed angle. Its intercepted arc is the 115. So again, you can just take half of 115. That's how you get the 57.5. And then there's a few different ways you guys can find angle Z. One thing you can do is you can look at angle Z, so I'll highlight this in red. It is an inscribed angle. So you can find its intercepted arc AB, and then you can just take half of it. So since we're given the two other arcs of the circle, we know a whole circle is 360. You can add the 115 with 75. You're going to get 190. You can subtract that from 360, which will give you 170. And then if you know this arc AB is 170, you can then take half of it to get Z. Another way is you can use property of triangles. You know that angle X plus angle Y plus angle Z will add to 180, so you also could have added what you got for X and Y earlier and then subtracted from 180. All right, next problem, number 2. The answer for the measure of arc WY is 64 degrees. So again, if you got this correct, feel free to move on to the next problem. So for this one, we are given that segment XY is a diameter. So right away you should be thinking, okay, my circles are being cut in half into semicircles. I know this is 180. I know this entire side is also 180. Now we're also given that the measure of angle XYW is 58 degrees. So XYW would be this angle right here. And the goal is to find arc WY. So let's start with that given angle. I'm going to highlight angle XYW. So this is an inscribed angle. Whenever you have an inscribed angle, you want to think about its intercepted arc. So the arc that it's opening up to is XW. So in order to find that arc, you are going to double the angle because that is the rule for inscribed angles. This is going to be 116. And then we're going to use the property of the 180 because you have a semicircle. Subtract the 116 from it, and that will give you the missing arc WY. So that is 64. Okay, for number 3, you are trying to find the measure of arc SAT. So this answer is going to be 240 degrees. Again, if you got it correct, feel free to move on to the next problem. All right, so we are given that this triangle SAT is equilateral. So that means all three sides are equal. So let's talk about what you guys remember about equilateral triangles. If you have three equal sides, you're also going to have three equal angles. So if angles S, A, and T are all equal, and we also know they're going to add to 180 because that's a rule about triangles, how big are each of those angles going to be? They're naturally going to be 60 degrees. Now the goal is to find the measure of arc SAT. Now, we do not have any diameters in this picture, okay? There's no center that was drawn, and we were not told that we were given any diameters. So we just got to think about these individual angles. If I were to take a look at angle S, that is an inscribed angle. So if I were to look for its intercepted arc, which is actually AT here, that arc is going to be 2 times angle S. So this arc is 120. Now, if I were to look at a different inscribed angle, let's say angle T, I'll highlight this in blue, its intercepted arc is SA. So again, that's just going to be double the 60. So again, I have another 120. I could also find the intercepted arc for angle A, but we actually don't need it because we're just trying to wrap from S all the way to T. So this entire arc measure from S all the way to T is going to be 120 plus 120, which gives us that 240. Okay, number 4. So the answer for the measure of arc BC is going to be 96 degrees. So let's take a look at this. So we're given that the measure of angle AED is 92 degrees. So let's label that. And we're given arc AD is 88 degrees. And we're trying to find arc BC. So notice how angle AED is not a central angle. There's actually 2 ways of figuring out this is not a central angle. First off, we're not given the center of the circle. And second, if it was a central angle, then it technically should be the same as its minor arc. So 92 is not the same as 88. This is also not an inscribed angle, because if it was an inscribed angle, the vertex of the angle would be on the actual circle. And it's not. It's here somewhere inside the circle. So it's not a central angle. It's not an inscribed angle. It's also not a CT angle, because we don't have a tangent line here. So this is one of those scenarios where it doesn't fall under any of these 3 categories. So this is going to be a situation where I have 2 chords that are intersecting inside of a circle. And I'm going to want to use that equation that the angle equals 1/2. And then I'm going to either add or subtract my arcs. So if your angle is inside the circle, what does that mean you do? It means you're going to add. So I'm going to call this missing arc X, and I'm going to fill in what I know. So my angle is 92 degrees. Drop down to 1/2. And I'm going to add arc 1 plus arc 2. So I'll just call arc 1 88. Arc 2 is my missing one. We'll call it X. So I can't combine 88 plus X because they're not like terms. So what we're going to do is we're going to distribute the 1/2 to both of those terms. So half of 88 is 44. And then you can just say 1/2 times X, which is 1/2 X. Feel free to also make it a decimal, 0.5x. So now we're going to subtract 92 minus 44, which gives us 48 equals 0.5x. Now you are going to divide by 0.5, and you will get 96. Okay, for the very last one, you have to draw a picture, but I'm going to give you the answer. The answer is that the angle is 25 degrees. So let's figure this out. So it says you have two tangents of a circle. So here's my circle. You guys remember tangents are like those hit and runs. Okay, so I've got a tangent line traveling. It's going to hit my circle. It's going to keep going. Okay, I'll move my circle up a little bit. Now I have another tangent that's going to do the same thing, but these are going to meet at an external point. So that means my two tangents are going to meet here at this external point. Now it says when this happens, they create a major arc measure of 205 on the circle. So you can see I have two arcs. I have the smaller arc and I have this major arc. So that major arc is going to be labeled 205 degrees. And we're trying to find the measure of the external angle. So again, this is one of those situations where you're going to use that equation, angle equals 1/2, and then you're either going to add or subtract your arcs. Well, since I have an external angle, I'm going to end up subtracting my arcs. So you'll notice that I know this arc is 205, but I don't know the other arc. As soon as I find the other arc, I can then just plug in my info. Well, you guys know that a full circle is 360. So if I'm given the major arc of the circle, 205, we can subtract it, and we're going to get that missing arc, which is 155. So now we can just plug in everything that we know into this equation. My angle is x, drop down the 1/2, and whenever you're subtracting, you always take the bigger arc first. Otherwise, you're going to end up with a negative number. Okay, so order of operations, let's just subtract. 205 minus 155 is 50. And now I'm going to take half of it, and you get 25 degrees. All right, let me know if you guys have questions, and we're going to continue reviewing on Monday because you guys have your quiz Tuesday. Have a good night.